the third video in the RTF series. I hope until now you have been enjoying all the content that has been provided as part of the series. In this video, we will particularly focus on namespaces, pods, services, and cron jobs. And eventually, we will also log into the cluster and check all the pods, services, and cron jobs. So let's get started. Freshly installed version of the appliance model of the runtime fabric will have three namespaces. First is the RTF, second monitoring, and third cube system. Now in case of RTF flavors other than appliance, you might not have the monitoring namespace. Now let's list out each pod in the RTF namespace. First is agent. As we discussed in part 1 of this series, this pod handles all the communications with the Anypoint Platform control plane. Second is certificate renewal. The agent uses two-way SSL to communicate with Anypoint Platform, which requires certificate to be installed on agent. This certificate has validity of around a year, and this pod's responsibility is to renew the certificate. Third, cluster status. The RTF status that you observe on platform is possible because of this pod. Its job is to monitor the overall health of this cluster and send data to the control plane via the agent. Fourth, initial cluster status. This pod works on updating the cluster status when it's initially being formed. Fifth is the Mule cluster IP service. Now this pod essentially enables a Hazelcast multicast network discovery mechanism so that in case when you create more than one replica of your Mule app and it's scheduler based app, it ensures that the scheduler runs only on single replica and not on all the replicas. Sixth, registry creds. The runtime images are stored in a private Docker registry hosted on AWS. To access the registry, credentials are required, and this pod helps to retrieve and store those credentials. Seventh, resource cache. Well, we have already discussed in first video of this series, but I'll go through it in a brief. So once we have the runtime retrieved from the Docker registry, we need to deploy an app to it. This app is retrieved from Anypoint Exchange. Once retrieved, it's stored in the cache to avoid reaching out to the platform or the exchange in case when app crashes or it tries to deploy multiple replicas of the same app, thereby reducing the round trip. Now let's move on to the pods in the monitoring namespace. So the first one is Grafana. It is a dashboard system that provides visualized information by leveraging the data which is stored in the InfluxDB. Next is InfluxDB. So it's a database that stores monitoring time series data. Third is Capacitor. It is an alerting system that streams the data from InfluxDB and sends alerts based on configurations. Fourth is the metric server. Its job is to collect metrics and push it to the InfluxDB. Fifth is the net health. Now, as the name suggests, it's a connectivity probe that does ping checks. Sixth is the heapster. Now, it monitors Kubernetes components and reports statistics and information to InfluxDB about nodes and pods. Seventh is Telegraph. This is an agent for collecting, processing, aggregating, and writing the metrics. Moving ahead to the cube system namespace. Now first is the core DNS and second is the core DNS worker. As obvious from the names, they both are responsible for DNS resolution. Third is the Gravity site. It exposes a web page for monitoring and administrating the RTF cluster. We have seen this web page in part 2 of this series, the web service that listens to HTTPS request on port 32009. So that's the service which is hosted by this Gravity site pod. The fourth one is log collector. It basically collects log from the fabric. Fifth is the log forwarder, forwards the logs which are collected to the external systems. Next is the tiller deploy. So this is the server portion of Helm and other related hook jobs. And sixth is the RTF install hook. It's a hook job that performs certain activity when the hook is triggered. So these are the three main namespaces. Apart from this namespace, you can have other namespace which when you deploy your app. So if you deploy an app in the dev environment, you will have a namespace which has the ID of that particular environment. So each environment will have its ID, and that ID will become a namespace. And any app deployed in that environment gets deployed to that particular namespace. So next up we have the services. Now services are used when two pods need to communicate with each other. So the only pods though that needs to communicate are fronted by some service. So for example, the deployer, it's basically fronts the agent pod and it's a node port service. Mule cluster IP service, we have a pod with the same name. So it's a cluster IP service which gives basically an internal private IP from the pod network. Same is for the resource cache. Whereas other three remaining pods which were there, they do not have any services fronting them. So which means that they are most likely scheduler based pods. In the monitoring namespace, we have Grafana as cluster IP, InfluxDB also as cluster IP. So we have pretty much all of them except for the Telegraph node, which doesn't have any services in front of it. Similarly, for a Cube system, we have Cube DNS Worker, Gravity side, it's load balancer because it's exposed to the external world. And then we have the log collector, which is of type cluster IP. Now, like I said, some pods might be run through a scheduler. So this is achieved using cron jobs in Kubernetes. So let's check those. So only the RTF namespace has cron jobs, and there are total of three cron jobs in the RTF namespace. So let's understand each of those. So certificate renewal, we have already seen there is a pod named as certificate renewal whose job is to update the certificate when it's about to expire. So this cron job ensures that the pod is triggered whenever the certificate is about to expire. Next is the cluster status, like we saw in the previous slides that the cluster status pod's job is to update all the status to the Anypoint platform. So this cron jobs triggers the pod at every 5 minutes. And the certificate renewal pod, it runs on this cron job expression. So it basically triggers on every Sunday at 12 a.m. And next is the registry credential. So we saw in the previous slide that registry credential is required. This pod gets the credentials that are required to log into the private Docker registry. So for that, this cron job is responsible, and this gets triggered every ninth hour. Now, the interesting thing over here to see is that the certificate renewal and the cluster status. Now we see that cluster status runs every 5 minutes. So what usually happens that one of the tasks of cluster status is to also check the certificate that's being used by the agent. So in certain cases, when the certificate is about to expire in the next 20 days or maybe 28 or a month, assume I don't have the exact number, but it's around a month when it's about to expire, the cluster status triggers and it pushes the status as degraded every time because it runs at every 5 minutes, right? So if it's about to expire on maybe a month later, it will publish the status as degraded, despite the fact that the certificate is still valid. But eventually, the certificate renewal would run on some week on Sunday before the time expires of the certificate, and it would replace the certificate. So that's one point where I mean you might get confused with the system degraded status appearing, but that's how it is. So here's the slide that has namespace, pods, and cron jobs. all put in a single frame. So this would help you to summarize what all we have seen from namespace pods and cron jobs perspective. So basically there's a column with monitoring RTF cube system, and all of this rows belong to monitoring, this to RTF and cube system. So all the pods are listed. Now the corresponding service, I mean the Grafana pod is fronted by the Grafana service, so it's present in Flux with InfluxDB. So services fronting the pod are also present, and the types of service that is also being mentioned over here. And then we have the cron jobs and the schedule. So this would give you a better idea. I mean, it's a summarized view of what we have seen in the last slides. Now it's time to validate what all we have understood in the slide. But before we do that, let's see what changes have occurred in the nodes since we installed Runtime Fabric onto it. So I have logged into all the three nodes. The node that has a private IP that ends in 44, which is this one, is a controller node, while the rest, the 203 and 111, are all the worker nodes. All right. So let's check out the controller node. What changes have occurred since the time we installed Runtime Fabric? So whatever changes are there, there would be some installation, and the files and everything will be present in the Runtime Fabric folder that we just created. So let's just have a look at what files have been added. So currently, let me check. Okay, let me list all the folders. So we need to go to OPT. Now make sure that you log in as a root user again to check things. Otherwise, you won't be able to get access. So any point, runtime fabric. Let's list. So initially we just had env and init.sh files, but now we have installer, installer tar, zip, and rtf Now installer is extracted from the star file, which is basically used for installation since this was a controller node. Apart from this, you might also find some hidden files, which is .rtf and .state. Now, important folder over here is the .state folder. So in case when your installation gets stuck at some point and you're facing any issues, so when it fails, and if you try to again run the init.sh, it will start from the point where it failed. So that those details are persisted into this .state folder. So in case if you want to start the installation again for a particular node from scratch, all you need to do is remove the .state folder. So that will help you get rid of uh, all the steps that had been performed, and it will perform the all the steps right from the beginning. So let me just enter into one of the folder, which is state, and see what it has. So let's list all the data files. So we have these are basically the steps that we have seen right in the file. So these are all the steps that have been encountered. Now let's try to open some of the files in it. For example, let's see fetch underscore rtfctl. So we are not able to view any of the contents, which means that since the installation is successful, I assume there would be nothing inside. But yeah, it's good to know that this .state folder keeps track of everything during the installation phase. So in case if it fails midway, the next time when you run, it resumes from the point where it failed. All right. So that's about the folder structure or the changes that we have seen in the controller node. Now let's move to the worker node and let's see what changes we see. So again, let me check. Okay, now let's move to OPT, AnyPoint, and Runtime Fabric. Okay, let's list all the files along with the hidden ones. So again, here also we have the .state file, we have env and init file. This is what we created. Apart from this, we see two new files which we didn't see in the controller, which is gravity and gravity system.log. So these are used to install gravity, whereas in the controller, it's part of its other step. So maybe for that reason, it doesn't have uh, that gravity file placed in this folder. And we have RTF We also had the same in controller node and the dot state file. So again, the dot state file will also have similar structure as the one we had in the controllers, just that this will change based on the steps that were performed, and those steps can be found in init.sh. So that's the folder structure and the changes that we have seen. Now, what we need to check is, let's see what all command line interfaces do we have access to. So let's go back to the controller node and first observe what command line tools we have right now. So first you will get access to kubectl. Let me type kubectl and I can see it's giving me list of commands that I can use with kubectl. Second, you get access to RTFCTL. So to access that, you need to use dot forward slash RTFCTL, and it gives me a list of all the commands. Okay. Next up, we have gravity. Now I've discussed about gravity in the first two videos. So uh, you can use gravity also, and I can see in controller I have access to gravity. Okay. Now let's move to the worker node. Now I'm not checking on the third worker node because controller and worker, if I check on one worker, it obviously has to work on other workers as well. So I'm just taking one worker out of the two. Okay, now let's see what access do we have. kubectl, we have an access on worker. Do we have access to RTFCTL? Of course we have, because that is what we saw right in when we listed all the files. So RTFCTL we do have, and we should also have gravity. All right, so kubectl, gravity, and RTFCTL access is available on all the nodes, that is controller and the worker nodes. All right. Apart from this, I have also said that there would be the pods will form their own network, and the container networking interface that they'll use is flannel. So let's just verify if it's flannel or not. So ideally you can use ifconfig command, but unfortunately it's not installed. So optionally you can install it by using yum install nettools. Otherwise you can, simple thing is enter gravity. So right now let's go back to controller and then enter gravity. So first we'll see the controller. So in controller I have installed ifconfig, but in case if you don't have, it's good idea to enter gravity. Now gravity, as you know, it is a root container, planet container, in which Kubernetes and all those things will be installed. So now by doing gravity enter, I have entered the container. Now this container provides me ifconfig command. So let's use that and see if the interfaces that I discussed have been installed or not. So if you observe, the CNI is there, but the implementation for CNI is done by flannel. So we have flannel, two interfaces for flannel. So this means that the container networking interface is being implemented by flannel. There are other vendors also like Calico, but RTF uses flannel. Now there are a lot many details inside this interface if we see veth, but if we're going through each of this detail would be beyond the scope of this video. So I'll keep our understanding until this point only, just that we know that it's flannel that's used behind the scenes. Similarly, we can also check on the worker node. So again, we need to do gravity enter because we don't have ifconfig. And inside we can use ifconfig. So if you see the CNI, then you see flannel. Okay, IP addresses are different, and that's quite obvious because they form a part of a different network. The IP address that this physical node has is can be given by veth. Let's see. So these are all IPv6. This is the loop back. And okay, so this is the Ethernet interface which has the IP address. So this is the IP that's attached to this node. Whereas all this CNI, Flannel, VH, these are all virtual IP, so virtual Ethernet frame interface. All right, so we have seen that the container network interface and Flannel's implementation has been applied. Now, also what you can do is you can check the status of gravity. So let's check gravity status and it will help you to get the whole cluster status. So right now we see that the cluster status is active, application is runtime fabric, the version, then the last completed operation, it was operation expand, of course, because the last node that was a worker node is what we added, and you can see the timestamp 2 days ago. You have the authentication gateway, cluster management URL. So we know that this is the op center URL. And now you can see all the nodes. This is the master node, and these are the other nodes. And we can see they are in healthy and online condition. So it's called as controller, worker, and these are the private IP addresses that we can see. Now ensure that I've already said this, but I'm telling it again that private IPs should be static when installing RTF. When you use AWS, you always get private static IPs. So that's not an issue. In case if you are using on your own bare metal servers and if they have IPs that change when the system crashes or stops, then it would be difficult because it uses this private IP address to discover each other. So we can use gravity status to check the status of the complete cluster, and this can be used in both in uh, controller as well as the worker nodes. Now let's check the namespaces, pods, cron jobs, and services. So we can check all of those while being in the planet container, or we can choose to come outside. So let's come out of this container. Let me enter exit. I'm out of the planet container. Now let's execute a couple of kubectl commands. So kubectl get nodes will give me the list of all the nodes. So right now I see 3 nodes. 44 is master, whereas all others are worker nodes. All right. Now we need to see the pods. So kubectl get pods hyphen, we'll see pods of all the namespaces. So double hyphen all namespaces. Let's hit enter. So we see a couple of pods belonging to different namespaces. So cube system appears to have many pods, then monitoring, and finally the least number of pods are in RTF. So cube system pods are ones that form the part of the Kubernetes cluster, basic components required for the Kubernetes control plane. Monitoring is something that RTF provides, and RTF is also something that RTF provides. So this monitoring and RTF namespaces are created by MuleSofts, having MuleSoft specific things. And the kube system name will have Kubernetes plus gravity specific pods. All right. Now here we don't have much detailed view, rather we just have ready one by one means there were one container and one is ready. So 0 by 1 means none of them is ready out of 1. Okay, and it entered the error state. We see some of them are completed, which means that the pod started and it exited by doing some of the task. Running means this are the servers. These are basically servers which have to be up and running to perform their tasks. So all of them are running, but most of them, I mean, most of them would be in running, but you can also see some of them are in completed and some of them in error. Errors are error, but they eventually run again and then they go to the completed state. Now, completed states would be some pods that basically run on schedule. For example, we have seen, right, the cluster status basically runs through a cron job. So it runs sometimes and after a certain duration and then it stops because its job is to run only after a particular interval, right? So why to waste resources by keeping it up and running? Just start, end the task and finish. So if you see the age is 2 minutes 21 seconds, so it might have ran recently, a couple of minutes ago. Now let's get a detailed view of this. So kubectl get pods, you can use -o wide. So executing this command gives us detailed view of all the pods. So what we essentially get is the IP address of the pod along with the IP address of the node on which the pod is hosted. Now if you observe core DNS pods, we have three pods, one that belongs to the controller and the other two belong to the worker. So 44 is controller, 111 and 203 are the workers. Now this additional extra part that comes into picture is to uniquely identify a pod if the pods are of same name, right? For example, here we have telegraph node uh, worker. So there are two that we see, right? So to uniquely identify, it adds additional characters at the end. All right. So the job of this three is to uh, cater to DNS resolution requirements. So whenever the pods get deployed, they'll have a cluster IP, and that cluster IP would have a fronting domain name, right? So using that, anyone can access. So you enter that domain name. For example, it could be the pod name or .svc.cluster.local. That would eventually resolve into an IP address, and you can eventually reach out to the pod. Then in the kube system, we have other pods which are now in completed state. So completed means that they were one-off pods and they, I mean, their task was only once and after that they are not required. So basically when the runtime fabric was getting installed, few of the components might have been required. They did their job and they ended up in completed state. All right. And ready 0 by 1 means one replica and 0 is ready right now because they are in completed state. All right, then we have the log collector. Log collector is only sitting on the controller node, whereas the log forwarders are sitting on each nodes. So controller, worker A, worker B, and they have their own pod, different pod IPs. Again, there are a couple of pods which are in the error state, possibly due to the errors that we encountered during installation, but eventually they succeeded because we see that uh, they are in the completed state, right? The about two one were in error, but later on they succeeded, so it's in completed state. And all of this was happening on the controller node. Now again we have the monitoring stack. So in this case also we have a a couple of pods which are in controller and couple of pods which are on worker. So this is one example wherein we have metric server and net health on the workers. So if you see net health, right? Uh, Net health is you have seen it's a connectivity probe which does ping checks, right? So it's on all the nodes. And similarly, the telegraph, it's also on all the nodes. And some of them are only on the controller node. Now in InfluxDB, if you see, it's 2 by 2, so I think there are two replicas of it which are ready, and it's being hosted on the controller node. Same is for capacitor, it's also hosted on controller node. Then eventually we have the RTF namespace. Now RTF namespace has all the pods that belong to the controller uh, node. So if we see, all of them are on the controller. Now we also see that some of them are in completed state, right? So if I see here, it shows as completed cluster status. It's like I said, in cube system also we saw a few of them were in completed states because their job was to do installation. But now cluster status, as we have seen in the slide, right? This runs every 5 minutes to check the status of the cluster. So basically, this if it isn't completed, it's and the age is very close, it's like 4 minutes. So most likely it might be run by some cron job. So that is what we have seen, right? It runs through a cron job. Then initial cluster status. So initially when the cluster was deployed, we could see this job being ran and it's now in completed state. So if you observe most of the one-off containers that were created, right? This one, both are of 2 days, 19 hours ago, 2 days, 19 hours ago. So they did their job when the first time the cluster was created and then they exited. Similarly, the mule cluster IP service, it's in running state, but it was created 2 days, 19 hours ago in the point when the cluster was created. The resource cache, registry credentials. So we know that registry creds is also being governed by a cron job. So last it was run, so its age is 22 hours. So it was run long time back. And again, we have RTF install job and it's in completed state. So it was also used initially when the cluster was deployed. Okay, so this is so you can explore this further, but these are it's important to know that where the pod gets deployed and what is the IP address. Now let's move to the services. So let's use Cube. Let's clear the screen first. Clear kubectl get svc hyphen hyphen all namespaces. So we get all the services that are in the namespace. So we now see a default namespace and it's Kubernetes cluster IP service. This is present in the default namespace. Then these are all that we discussed in the slides. So Kube system has Gravity Site, which is a load balancer. And what it basically does is it's opening 32009 port on the node, all right, and it moves to 3009. So again, we can use the O wide flag to get a clear view. Let me just clear the screen. We'll run the same command with O wide flag. So when we run with the O wide flag, what we get is the selectors. And the job of this selectors is that if you apply this selector, any pod having this selector, with this selector, this services will get attached to those pods. Now, if we see, we have cube system, gravity site, which is a load balancer, and 32009 port is getting mapped to 3009. Similarly, we have gravity site auth, which is again a node port service, 32025 mapped to 3025. Now we have already used this when we try to access the op center. We hit the 32009 port of the node and it eventually gets mapped to 3009 and then it goes to the respective pod. We have the cube DNS of the controller, cube DNS of the worker, and we see that port 53, UDP 53 TCP 9153 TCP. So all of these ports are exposed for this pod. Again, log collector, Grafana, InfluxDB. So all of them have uh, the services and the required pods. So you can get a view of what all services are available from here. Now let's move to the cron job. So kubectl get cron jobs is the command using which you can Now I'm not getting this. Let me add all the namespaces. Namespaces. So once I add all namespaces, I get all the cron jobs. Now if you observe, we just have cron jobs related to the RTF namespaces. So certificate renewal is what we saw. It runs based on the schedule, which means that every Sunday at 12 a.m. cluster status runs every fifth minute, and registry credentials run every 9 hours. So last schedule, if we see, it was 22 hours to now. This might not exactly reflect the behavior because if you see, this was 22 hours, right? It should be rather 9 hours because I have been restarting the cluster again and again in between to save billing charges. So that is why it might sometimes be different. You might see some discrepancy. That's what I'm trying to convey. All right. So that's about the cron jobs. So we have so far seen the nodes, the pods, and the services, and the cron jobs. Now, in case if you want to know which service is fronting which pod, you can leverage this selector to know that. For example, if I want to know this, now from the name, it's quite obvious that resource cache service would be fronting the resource cache pod, right? But in certain cases, for example, deployer. Now we don't have any pod named as deployer in the RTF namespace. How do we identify that? So for that, you can simply use kubectl command, get pods, then use the selector flag, copy the selector. So what is the selector? It's app equals to agent. So selector equals app equals agent. This is the selector. Specify the namespace. So the namespace that we are trying to search is RTF. Hit enter. So we didn't get any result, but we should have got. The reason is that there is a spelling mistake. Let's correct this. Agent. And I think I should get result now. So this is the pod name that is being fronted by the deployer service. So similarly, if you want to get an idea of which service is on top of which pod, in case if the name of the service is different than the pod, you can use this command and get an idea of which service is being leveraged by which pods. Okay, so these commands were running perfectly fine on the controller node. Now we saw that we had the kubectl access on worker nodes as well, but can we really access all of these commands that we just saw? Well, let's try. So let's run kubectl get pods hyphen hyphen all namespaces. Okay, command not found. So there's a spelling mistake. It's kubectl. Let's hit enter. So it's not accessible. It's saying forbidden. Cannot list resource pods in API group at the cluster scope, which means that we can only access all of this in the controller node. But what if we try to enter the planet container? Let's enter the planet container. Gravity enter. Let's try to list the pods. Kubectl get pods hyphen all namespaces. The same thing, we cannot access in the planet container either. Okay, let's try the other node. Let's see if we have an access or not. Get pods hyphen hyphen all namespaces. Same here. Let's try inside gravity and let's use the same command. Pods hyphen hyphen all namespaces. So the same result, we cannot access the Kubernetes commands to list out pods or services or cron jobs on the worker nodes. We tried for pods. Let's verify if it works for services. Get svc hyphen hyphen all namespaces. No. Okay. Typo. Nothing. Not even services. Let's change this to cron jobs. Nothing is accessible. So this means that you always need to be logged into the controller node so as to run the commands. Although you have access to kubectl or the CLI tools in worker, but it's really of not much use because you can't do anything with those commands, right? So you always log into the controller node and you can leverage this commands. So that's all for this video. I hope you found the content useful. Thanks for watching.